Next, we want to talk about the types of data. There are four types of data in statistics. The first and the lowest level of data is what we call nominal data. As you can probably tell by the prefix in this word, nom, these data are characterized by names. The prefix nom means name. So these data are characterized by names or categories. Names or categories. For example, if we wanted to find out how many Republicans and how many Democrats we have in a group, we would simply count the number of Republicans, count the number of Democrats. These are examples of nominal data. These two categories. We can categorize a person as a Republican or a Democrat. Or even in some cases, we might have some members of other parties. Some members of other parties. And then we might have some individuals that are not members of any particular political party. So we could have many different categories of individuals as far as political perspectives are concerned. We might find in a group of, say, 100 individuals, we might find that we have 25 Republicans, 25 Democrats, 25 members of other parties, and 25 individuals that are not members of any party. So these are examples of nominal data. We use names or categories. That's about all we can do to this type of data. This type of data, we cannot really put these political parties in any particular type of order, from best to worst. Generally speaking, I'm sure that a Democrat would probably say that the Democratic Party is better than the Republican Party, and a Republican would probably say that the Republican Party is better than the Democratic Party, and what have you. But generally speaking, we say that we cannot put these in any type of order. So this is one type of data, nominal data. The next type of data is what we refer to as ordinal data. Spelled O-R-D-I-N-A-L. Ordinal data. Now within the word ordinal, you see the prefix "ord," which is very close to the word order. So ordinal data are data that can be put in order. Data that can be put in order. This is what we mean by ordinal data. Data that can be put in order. For example, your grade point averages, they can be put in order. Your letter grades, for example, A, B, C, D, F. Those letter grades, they can be put in order. Here, an A, we consider that excellent. A B would be good. A C would be average. A D would be below average. And an F would be failure. So we can put these letter grades in order. So the letter grades are examples of ordinal data because we can put them in order. Now, as you can see here, we can also give them names, or we can categorize the letter grades. When you have different levels of data, a higher level, or the ordinal level is a higher level than the nominal level. The nominal level is the lowest level. The next higher level is the ordinal level. Now, a higher level has to satisfy the conditions of the lower levels also. So that's why the ordinal data, not only can it be put in order, but we can also have names. We can also have categories for ordinal data. And this is how it is with the other two higher levels of data. They satisfy the lower levels also. So we're saying here, we're giving the distinguishing characteristic of this type of data. Now, a lower level data cannot become a higher level. Theoretically, nominal data that would be the highest level. If we classify data as being nominal, that would be the highest level that that data can have. If we classify them as nominal, that would be the highest level that they can have. If we classify data as ordinal, we are saying that this is as high as you can go with these data. This is as high as you can go. You can't go any higher. So you can see what we're doing here as far as the ordinal data is concerned. The ordinal data satisfies the requirement that we can put them in category. They satisfy the requirement that we can put them in categories, and also they satisfy the additional property that we can put them in order. Now, the next higher level of data is what we refer to as interval data. Interval data. And interval data satisfies the two previous mentioned types of data. Interval data, we put interval data in order. We can categorize interval data, and interval data has the additional property that we can subtract one number in the data set from another number in the data set and get meaningful differences. So we'll say that interval data are data that have meaningful differences. They have meaningful differences. And also, they have no inherent zero. Interval data have meaningful differences and no inherent zero. An example of interval data is the temperature scale. We can look at the Fahrenheit scale, and we can say that on Monday it was 30 degrees Fahrenheit. On Friday it was 40 degrees Fahrenheit. We can subtract these two and we can get a meaningful difference. We can subtract these two, 40 degrees minus 30 degrees, and we can say that there was a 10-degree difference in the temperature of Monday and the temperature of Friday. So we can get meaningful differences. IQ tests would be another example of interval data. We can subtract IQs and we can get meaningful differences. We can say this person's IQ is 20 points higher than that person, and what have you. The interval data do not have inherent zeros. They do not have inherent zeros. For example, if we talk about the freezing point of water, if we talk about the freezing point of water, if we look at the freezing point of water on the Fahrenheit scale, degrees Fahrenheit, the freezing point of water would be what? 32 degrees. Right, 32 degrees. If we look at the centigrade scale, degrees centigrade or Celsius, the freezing point of water would be 0 degrees. So there is no real inherent zero when you have an interval scale. Where is 0 degrees located? Is 0 degrees 32 or is 0 degrees 0 degrees? The freezing point of water, I'm saying. Is the freezing point of water 32 degrees or is the freezing point of water 0? So you don't have an inherent zero. And there are other temperature scales that I'm sure you can think of. Many of you that have had chemistry and physics, you know that there's a temperature scale that's used in chemistry and physics, and you probably can tell me what that temperature scale is. What is that temperature scale? What do you think it is? What is it? Can you recall the temperature scale, another temperature scale, aside from the Celsius and the Fahrenheit that you used in your physics or chemistry class? That's right. Kelvin, the Kelvin temperature scale. It's another different temperature scale. You have another different idea of the freezing point of water. And the other indication of no inherent zero is the idea that a person has an IQ of, say, 100, or say 120, or what have you. The person that has an IQ of 0, it's just not conceivable that a person could have such an IQ of 0. Ratio data are data that have an inherent zero. This is the distinguishing characteristic of ratio data. Ratio data is the highest level of data. That means that ratio data are the highest level of data. This means that ratio data satisfy the requirements of interval data. If we subtract two elements of ratio data, we get a meaningful difference. Ratio data satisfy the requirements of ordinal data. They can be put in order. Ratio data satisfy the requirements of nominal data. We can give them names so that since it's the highest level, it has to satisfy the requirements of all the other lower levels with the additional property that there is an inherent zero. Examples of ratio data are weight and height. Those are examples of ratio data, weight and height. A person's weight, for example, or the weight of some mass or some quantity. Weight, if a person weighs 0 pounds, if it were possible for a person to have a weight of 0 or have no weight, it would be the same regardless of what scale you use. If you use pounds, for example, if a person doesn't have any weight, if it were possible for a person not to have any weight, the person would weigh 0 if we're dealing with pounds. If we're dealing with grams, which is another weight scale, a person that does not have any weight in pounds would have 0 weight in grams also. And the same with kilograms and other scales of weight. So weight has an inherent 0. There is an inherent 0. The same thing with height. If it were possible for a person to have 0 height, if we measure the person's height in inches, the person's height would be 0. If we measured the person's height in centimeters, the person's height would be 0, and so forth. So there is an inherent 0 when you're dealing with these two concepts. Now, many of your physical quantities are ratio data. For example, the weight of radioactive substances. It is an example of ratio data. The distance between the nucleus of an atom and the outer orbit, or the outer electron, or electronic orbit. There's the idea here of an inherent 0 in addition to the properties of the lower levels of data. For a quick review, once again, lowest level of data is nominal data. They have names or categories. Next higher level, ordinal data, they can be put in order. Next higher level, interval data, they have meaningful differences, but no inherent 0. And the highest level, of course, ratio data, there is an inherent 0, plus you have satisfaction of the properties of all the lower levels of data.